Hello everyone, my name is Diana Phillips, and today we are going to be discussing geospatial analysis within the deep sea. I work on this research project with my partner, Manuel Ploner, and we assess distributional patterns of Mesopelagic Scyphozoa within the Monterey Submarine Canyon in California. So one thing to keep in mind as we go through this presentation is that while I'm specifically researching Scyphozoans, you can absolutely use these strategies with any other deep-sea organisms, and this is a unique application of GIS within the oceanographic realm. So for a short introduction of what this project is about, basically we collect our data from the Monterey Bay Aquarium Research Institute, or MOMBARI, which has remote operated vehicles, or ROVs, which run through the waters surrounding California, observing organisms in the mesopelagic and bathypelagic zones of the ocean, and utilizing their video annotation and referencing system, also known as VARS, they associate photos taken by these robots and they connect them to genera identification, GPS data, and water quality information. And so we can utilize all of this to gain greater context for the environment in which these organisms were found. So here are examples of what images from one of those ROVs might look like. And so here's how we did some of our spatial cleaning within our project. So when we began this project, first was our ability to map the raw data. So when I originally had this project, I tried simply plotting 5 points utilizing Google Maps, but it's very difficult to plot this volume of data without being able to use GIS. And so being able to use it spatially, I was able to identify that some of my organisms found were not only found within my potential survey area, which was in California, but they were found, in fact, across the world. And so it was really important to be able to view these spatially and do the upcoming analysis, which wouldn't have been possible without GIS. So each of these points represents a jellyfish observation from an ROV. This is already cleaned data, which has removed duplicates, missing variables, and those with inaccuracies or inconsistencies. So the next step of this project was to do a hotspot analysis to see where the majority of these jellyfish were recorded, and we see that the majority of them are recorded in our Monterey Canyon. So then, outlining this canyon, utilizing the draw tool, we were able to choose a median point and then create a buffer that would become our survey area. So utilizing a 10-kilometer buffer ended up being the most effective option, as it encompassed 69% of all observations of Scyphozoans, and considering that there were Scyphozoan recordings across the world, being able to capture 69% of that data was very good for this research project, because it allowed us to have enough replicates of data to create greater and more informed analysis. More effective analysis. So the next thing that we did is we visualized each of our genera, and we assigned each of these different colors so that visually it was easier to tell, for instance, which genera were more common and which genera were less common. And additionally to that, we can see spatially how they relate to one another. One thing to keep in mind when you're observing this is that while there are more genera near shore, that is more so the result of research effort, because it's easier to get a boat close to shore than it is to get it offshore, and so that's part of why we see such a large clustering of Scyphozoans near shore. So the next step of this research project was to start looking for other data that could support conclusions that I was hoping to draw within this research project. So I utilized raster data that was provided from ArcGIS, utilizing the Oceans Initiative, where they publish a variety of ready-to-use open data for the goals of this project. Depth zones was one of the more helpful layers available to me, and it allowed me to provide greater context to my findings and do additional data cleaning that was not possible before utilizing this raster data. So part of utilizing that raster data is creating context for observations. So what are creative ways that researchers can utilize geospatial tools in open data to better understand and contextualize their observations and the results of their analysis? So one example of this was, first I plotted all of my points within a My Scene, which is a viewer that allows you to see things in 3D instead of just in 2D. And upon initial observations, you can see that as we become more near shore, there are jellyfish observations which are particularly high in depth, potentially to the point where they are inaccurate observations. And so one of my curiosities is, how can I use geospatial tools in order to solve this issue of being unsure whether or not that's an accurate reading? So the first thing that I did was I clipped that raster data and confined it within my survey area. And then after I did that, I utilized a raster to polygon tool in order to turn it into a polygon. Once it was within the polygon, I was able to put it back into the My Scene viewer and put all of those depth zones into their respective depths. And the result is that I can see some of these jellyfish are indeed exceeding in height more so than the depth zones, which would be the bottom, so the maximum depth it could be, which indicates that points such as these 2 points are inaccurate and need to be removed from our data set. And so that allows me to come to more accurate conclusions when I'm doing my statistical analysis, because I'm removing impossibilities or outliers. So another big portion of this project occurs not just in GIS, but also in R. So within R, I do a variety of different analysis, one of which is the ggplot, and so I utilize ggplot to create violin plots, which allow me to better contextualize my data in relation to each other, so looking specifically at each of these genera. And then I also utilize TS profiles, which allow me to contextualize them versus our equatorial and polar water masses. And so there's definitely a lot of other really cool results, but this is largely the geospatial component that was utilized within this. So this was all shown to you in a this was all demonstrated within a Thank you so much for attending.